Okay, in this notebook, we're going to explore inheritance. And we're going to do this with a person class and then a patient class. And I'm not going to talk over all the details of everything. We'll kind of do more high level. This is very similar to what we did with the point class or the shelter animal class. I have my constructor, which again, provide my self argument. I have first name, last name, middle name, sex, date of birth. And then I'm just going to have this catch-all keyword args that I'm not going to use in this class. This will just make it robust if someone types in some other keyword arguments that they'll just get ignored. An important point here, though, is what am I deciding is the essential attributes of a person? That's what's going into my class. And I can't model everything. And so in this instance, my person is very simple. A person is someone that has a sex, they have a first, middle, and last name, and they have a date of birth. I could have had weight, I could have had height, I could have had race, uh, all sorts of other things. But in my program, a person is just essentially a name and a birth date and a sex. For the first time, we're doing some stuff with dates, and so I'm making use of let's see what we imported up here, the date time, which is part of the Python standard library, and date util, which is a third-party package that we've installed, and time, which is part of the Python standard library. And so the key here is how I'm dealing with date of birth. So I'm going to assume that date of birth is passed in as a string, well, none, or else it's a string, and then I'm going to parse that string into a date-time object using the date util parser, which I'll illustrate in a little bit. All these things are properties, and so I can return the date of birth, but I don't provide a setter. Once the date of birth is specified in the object, I figure that's something that's immutable. The time that I was born was the time that I was born. If something was specified incorrectly on creation, then I would have to create a whole new object. So we're using properties here. I do a little bit of, if I didn't provide a name, then I'm going to have like the standard Jane, John Doe's, if something else wasn't provided. And then I'm defining some methods that are kind of like our greeting method that we defined for our shelter animal. So get full name is just going to return a string that has my first, middle, and last name. And get characteristics is a method that's going to return a string that provides more detail about the person. And you see when I defined age, I just decided, well, my age, again, which is just a property, it's not something that I can set, because what I'm going to do for my age, and this was the question I asked in the shelter animal, is I'm not going to provide an age. I've provided a birth date. And then I'm going to always compute an age. And I'm going to do that by taking what's the current time and subtracting my date of birth. And that's going to give me a time delta object, which is a class definition in Python. And then I am going to return the years. I'm going to return my age as a dictionary, which consists of how many years and months old I am. And so I just compute that straight from my arithmetic. Okay, well, how does this work in practice then? So I can create a variable that I called me, which is an instance of a person, where I provide my name, middle initial, my sex, and my date of birth. And when I go through this, it creates an instance of me, and then I can call me and get my full name and print that out. Oops. Or I can call this get characteristics, and it provides this string. Well, let's play around with this a little bit. We did do some error checking kind of things. Did we have anything for sex? I think sex is pretty straightforward. I just take a string, so I could provide anything for my sex. I just lie? I just lied. I didn't see close enough that sex must be male or female. Hope that isn't offensive to anyone. But what if I tried to provide a date in a different format? So 1968, 05, 24. Oh, it's able to figure that one out. If I do 24 May 1968, can I ever break this? Oh, that parser is doing a pretty good job. What if I do May's 24, 1968? Then it's choking. I can't parse that. If I do that, so that parser is doing a pretty good job for extracting my date of birth from the strings that I'm providing. Okay, so that's my person class. Well, now I want a patient class. And I know a patient's a person, so I don't want to start from scratch. So I want to inherit from person. So now my patient is going to have all the attributes that a person has. But I'm going to add in some things. So I'm going to say, well, a patient is someone that has a primary care provider. A patient is someone that has a chief complaint. And they have a medical record number. And now I'm really going to take advantage of this variable number of keyword arguments, because here, instead of having to repeat all the keyword arguments that I need for my person, they can all just be captured in this keyword arguments, and then I can pass the keyword arguments down to my person constructor. And the way I do that is with this super call. And this is something that's going to become very important throughout our use of inherited classes. Super is how we get access to the parent or the ancestor attributes and methods that we're inheriting from. So if I don't define my own constructor, the patient constructor would be the person constructor. But since I am now defining a patient constructor, the person constructor is hidden, and so I have to access it through this super method. And so the syntax for that is super, what's my current class patient, the particular instance of this self, and then which method or attribute do I want to call, in this case the constructor, and what arguments am I passing to it. That's my keyword arguments. And then I set my PCP, my chief complaint, and my MRN values. Again, these are all properties, and so I can do type checking, make sure that that my PCP is a string, etc. I have restriction on what my medical record number must be, so it must be a 12-character long string. And now I have also a get characteristics. Now that I have more things in a person, in a patient than I do in a person, and so when I generate my string, well, I want to get the string that describes a person, and I just want to add on the string descriptions that are specific to a patient. And so I use the super to call the get characteristics of the person class. That returns a string, and then I'm just adding on to it the things that are specific to the patient. So here I create a person, Brian, same kind of characteristics I was working with before. I have an age of 5 months and 49 years. You know, dictionaries aren't ordered. And here I'm going to create a patient instance of myself. So I'm going to call this patient Brian. And I'm going to pass it my name, all the things I need to describe a person. I'm going to provide who my primary care physician is, what my chief complaint is, which is usually research, and medical record number. So now when I print out my characteristics, I have all the things I had about me before. And you see here, I never defined an age method or age property. So that is all inherited from my definition up here in person. but I overwrote, I have my own get characteristics for person, and so here is my, for patient, sorry. So I have all my person attributes plus my patient attributes. Okay, so this is our first example of an inherited class. And so kind of analogous to our is instance that we've been using are these functions in Python called is it a subclass or a superclass. And that's where I can ask questions about where I stand in this class hierarchy. So is a person a patient? So is person a subclass of patient? False, it's not. But is a patient a person? So is patient a subclass of person? Yes. So anything I can do with a person, I can do with a patient. Is Brian a person? Yes. Is patient Brian a person? Yes, because a patient is a person. Is Brian a patient? No. Is patient Brian a patient? True. Yes, I am. So, and this goes to the thing about type classing that I mentioned in the previous notebook. So when I define a patient, I can treat that patient as if it were a person. Anything that a person can do, a patient can do. But a person isn't a patient. And so a patient has differences that aren't accessible by a person.